Electromagnetic railguns are a cutting-edge weapon system that operates using electromagnetic forces to launch projectiles at incredible speeds, far surpassing the capabilities of traditional firearms. Unlike conventional guns that rely on explosive propellants, railguns use two conductive rails and a magnetic field to accelerate a projectile, propelling it at hypersonic velocities. This technology has been gaining attention, particularly for military applications, as it offers the potential for highly accurate, fast, and powerful projectiles without relying on chemical explosives. In the context of fighter jets, the integration of electromagnetic railguns presents several exciting possibilities. One of the primary advantages of railguns is the immense speed at which projectiles are fired. A railgun can accelerate a projectile to speeds in excess of 8,000 miles per hour, significantly faster than traditional guns or missiles. This high velocity makes the projectiles more difficult to intercept, providing fighter jets with a formidable advantage over enemy targets. Furthermore, railguns offer a more efficient and safer form of weaponry. Traditional ammunition is often bulky and requires explosive materials, posing risks such as misfires or accidental detonation. Railgun projectiles, on the other hand, are small, dense metal slugs that don't require any explosive components. This makes the weapon less hazardous and allows fighter jets to carry more ammunition, extending their operational range without the need for frequent resupply. However, one of the biggest challenges with integrating railguns into fighter jets is the tremendous power required to operate them. Railguns require an enormous amount of electrical energy to generate the magnetic fields necessary to accelerate the projectiles. This means that fighter jets equipped with railguns would need advanced energy generation systems to provide sufficient power. Current fighter jet engines may not be capable of producing the required energy, making it a critical area of development. Another hurdle is the heat generated during the firing process. The electromagnetic forces that accelerate the projectiles also produce significant heat, which could potentially affect the performance of the jet's avionics and other systems. To address this, advanced cooling technologies would need to be developed to manage the heat and ensure the railgun functions properly during high-intensity operations. Despite these challenges, the potential benefits of electromagnetic railguns are substantial. In terms of performance, railguns could provide fighter jets with superior speed, range, and accuracy. This could lead to more effective combat strategies, particularly in air-to-air engagements, where the high velocity of railgun projectiles would make it difficult for enemy aircraft to evade. Additionally, railguns could allow fighter jets to engage both aerial and ground targets with great precision, increasing their versatility on the battlefield. The development of electromagnetic railguns for fighter jets is still in the experimental stage, with many technological hurdles remaining. However, the advantages they offer in terms of speed, firepower, and safety could ultimately make them a valuable addition to next-generation fighter aircraft. As energy storage, power generation, and cooling systems improve, electromagnetic railguns could one day become a standard weapon in the arsenal of modern fighter jets, transforming the future of aerial combat. The American Electromagnetic R.